the strangest worlds beyond our solar system. Beyond our solar system, there are worlds so strange that they make science fiction seem ordinary. Some planets may have clouds filled with glass, some are darker than coal, others orbit two suns. And some are so hot that metals can vaporize into their atmospheres. These worlds are not products of imagination. They truly exist among the thousands of exoplanets humanity has discovered. HD 1-89733b, the deadly blue planet. From a distance, it looks beautifully blue. It almost resembles a giant version of Earth, but that blue color does not come from oceans. Its atmosphere is filled with tiny silicate particles. In temperatures above 1000 degrees Celsius, those particles may create something like glass rain. The winds there can reach thousands of kilometers per hour, so the glass would not fall gently toward the surface. It could be blown sideways through the atmosphere at terrifying speeds. This world is a reminder that a planet can look beautiful from afar while being completely hostile to life. WASP 76b. This is a giant planet orbiting dangerously close to its star. It completes an entire orbit in less than 2 Earth days. Because it is so close, the planet experiences extreme temperatures. One side may remain permanently exposed to the star. There, the heat can become intense enough to vaporize metals, including iron. Powerful winds may carry that iron vapor toward the cooler night side. As the temperature falls, the iron may condense. It could then fall through the atmosphere like metallic rain, not rain made of water, but a strange cycle of vaporized and condensed metal. TRES 2b, a planet darker than coal. This is one of the darkest planets ever discovered. It reflects less than 1% of the light it receives from its star. That makes it darker than coal. If you could enter its atmosphere, you would be surrounded by almost complete darkness. But the planet may not be perfectly black. Its extreme temperature could produce a faint red glow. From a distance, TRES 2b might resemble an enormous shadow, with dim red light burning beneath its atmosphere. It is a planet that almost disappears, even while orbiting a bright star. Kepler 16b, a world with 2 suns. Kepler 16b does not orbit a single star. It travels around 2 stars at the same time. This type of world is called a circumbinary planet. From a nearby moon, you might see 2 suns in the same sky. 2 sources of light, 2 shadows stretching across the ground, and 2 suns setting beyond the same horizon. Kepler 16b shows us that worlds once imagined only in science fiction can truly exist. But 2 suns are not the only way a planet can experience a strange sky. On some worlds, the sky may never change at all. One side remains trapped in endless daylight, while the other never sees its star. A planet trapped between eternal day and night. Many exoplanets orbit extremely close to small stars. The star's gravity can synchronize the planet's rotation with its orbit. This means that one side always faces the star. That side remains trapped beneath constant light and intense heat. The opposite side never sees the star. It exists in permanent darkness. under freezing temperatures. Between these two extreme regions, there may be a narrow zone of endless twilight. A place where the day never completely ends, but the night never fully begins. But not every strange world remains bound to its star. Some planets are thrown out of their systems entirely, leaving behind light, warmth, and orbit. From that moment on, they drift alone through the darkness between the stars. Not every planet orbits a star. Some worlds may be thrown out of the planetary systems where they formed. After that, they drift freely between the stars. Scientists call them rogue planets. They have no sunrise, no sunset, and no nearby star to warm their surfaces. These planets may wander through the galaxy for billions of years, cold, dark, and almost impossible to detect. Somewhere between the stars, countless worlds may be traveling alone through the darkness. But some planets do not drift away from their stars. Some move dangerously close to them. WASP 1-2b orbits so near its star that a complete year lasts only a little more than one Earth day. The heat has expanded its atmosphere, while the star's gravity is slowly pulling that atmosphere away. From a distance, the planet may appear stretched, almost like an egg rather than a perfect sphere. A long trail of gas may follow behind it as it moves through orbit. This world is not being destroyed in a single explosion. It is being stripped apart gradually. Orbit after orbit. One day, the planet may lose much of its atmosphere, or spiral completely into the star that is tearing it apart. But extreme gravity is not the only force capable of transforming a planet. On another world, heat may be reshaping the entire surface. 𝘚𝘐𝘙𝘐 is a rocky planet orbiting extremely close to its star. One side may remain permanently exposed to intense starlight. Temperatures there can rise high enough to melt rock, creating enormous oceans of lava across the surface. But the heat may do more than melt the ground. Rock itself can vaporize, rising into the atmosphere like water vapor on Earth. Powerful winds may then carry this material toward the colder night side. There, the vapor cools, condenses, and falls back toward the surface as rocky rain. The material may eventually flow back toward the hot side, creating a cycle made not of water, but of stone. It is a weather system unlike anything found on Earth. Yet even a planet covered in lava may not be the strangest world we have found. Some planets appear to be made of material far lighter and far more fragile than expected. Kepler 5.1, the planets as light as cotton candy. The Kepler 5.1 system contains several unusually large planets. At first glance, they appear similar in size to giant worlds such as Saturn, but their masses are surprisingly low. Their average density is so small that scientists sometimes describe them as cotton candy planets. They are not actually made of sugar or clouds of cotton. Instead, they may possess enormous, inflated atmospheres surrounding relatively small planetary cores. These atmospheres are so extended that radiation from their star may slowly strip them away. Over time, the planets could shrink, and become very different from the worlds we observe today.